Hi everyone, so welcome to the talk of modularizing monolithic applications. So today we're going to be talking about how we can separate a big monolithic application. So we build enterprise, huge complex applications. We're going to talk about our journey in Evoke on how we actually separated and decoupled our big monolith. So what we're going to be focusing on today is the approach of creating a middle layer using a BFF pattern, a notation mark BFF, and I'll explain why. An API gateway, and for the front end we use a Monorepo. So a little bit about me. My name is Kire Simonovski. I'm a lead engineer with Evoke Systems. I've been in IT for around 10 years. I have a lead role now for 2. A little bit about Evoke and what we're modularizing is we create software solutions for the aviation. We have 4 domains where we focus our products on. So training management, leave management, which is holiday booking and management for crew, flight management operations, and then we have safe document storage management there. So if you want to learn more about Evoke and what we do there, we are local in Norfolk. Hit us up on evokesystems.aro. Right, so the overview of the talk today. So it's condensed talk, it's going to be 45 minutes. So we're going to talk about what is actually a BFF and how you implement one, what is a gateway and how you implement one. What I'm going to talk about is a journey on why we've implemented these patterns of design, and what was our thinking process behind the scene, what we were trying to solve, and what we've actually achieved doing that. So we're going to go through the problem. We're going to look at how we approach the problems. Key goals is key here. Hunting. So yeah, the key goals we wanted to achieve, specifically I say key goals here, is because we had plenty we wanted to do, right? We wanted to solve every single possible problem that we faced, minor ones, big ones. So we needed to make a proper roadmap, say, hey, these are the key goals we need to focus on. We'll talk a little bit about pros and cons on microservices and pure monolithic. We'll talk a little bit about BFF, a little bit about Monorepo at the end, and it's going to be a journey. So I hope it just inspires you in thinking more pragmatically. So prerequisites of the talk, there aren't any really. It will be beneficial if you know a little bit about the architecture, patterns of work, so how microservices are architected in their own structure, how monolithics work, deployment processes, all that. If you know a little bit about Angular, React, Vue, any modern framework, that's great, front-end framework, because we're going to be talking about Webpack and why we chose to build everything with Webpack. And at the end, or in the middle of the presentation, we'll talk about the BFF and the gateway and BFF in quotation marks, and why I say that. So the expected goal of the talk, and what I want you to reach from this 40 minutes, is to inspire you to just take a more pragmatic approach when you're solving your problems as engineers and also looking at architecture. Never leaving anything to magic is the topic of today. So it's kind of contrary to the keynote topic that was serverless is magic. This is going to talk about how everything that we do should not be left to magic. And it's a quote of my CTO, and there are stickers if you want to follow a trend called #NoMagic. It's quite opposite of what we're hearing in the keynote there. So let me talk you through what we had and what we still have as an old world, we call it. So this is a big monolithic application. This is kind of a timeline. It starts in the middle, it's weird. But we have, it's .NET. So if you're not familiar with .NET, if you're coming from a different background, it's really not, I'm not going to talk about .NET in specific, but I want to make sure that this is a .NET Framework 4.7, which is now almost 8 years out of date of the new .NET Core and .NETs. The main difference between these two, and this is why I'm putting these in the old world, is these have to target a Windows platform, while .NET Core can work on a Linux environment as well if you're hosting them there. And they're quite more lightweight. So let's begin. This is our old world. We have web forms projects, so ASPX Classics, ASPX Pages, modular architecture a bit in terms of how our components are designed, but it's pretty straightforward. So you have a code behind or internal controllers, if you might be familiar with MVC. You have ASPX pages on top of them that serve the clients. There is JavaScript and jQuery in these with a bit of Ajax as well to make asynchronous calls to our APIs. Shared business logic and data context. Now this is an important bit, and this is why we are modularizing everything. Our WebMVC is quite newer, so around 2014, 15, I think most of our products moved to WebMVC, but we still have legacy web forms. Very pure MVC. So controllers, internal controllers that have Razor pages underneath them, the Razor pages, Bootstrap, and Angular JS framework. That bootstrapping is happening through Gulp as a task runner and build server, and we have shared business logic and data context. At the end there we have a mobile API. Again, this is done in, I quote it as legacy because it is targeting the web forms project, and it is exposing controllers that our iPad app is using, and it has Swagger, came out 2011 or whatever. I mean, at the time this was written, it was really at that stage. So there is a web UI, it's an ASPX page that exposes our endpoints so that you can hit a button and see what the get does. Shared business logic and data context. Now this is important for those of you that are not .NET. It is important because .NET Framework 4.7, all of these projects can communicate to each other if you have a shared library that's targeting .NET Framework 4.7. Now, what were our concerns, right? Why did we want to start this journey, and why did we want to modernize our tech, and where was this all coming from? So the first thing that is not said here is we are in a process of growth. We know that we need to scale, and our infrastructure at the time wasn't scalable. The biggest thing was the monolithic applications were tightly coupled together. So remember that shared logic and shared services? That's all good when you're actually reusing them properly. But you have to be real here and think of the fact that this is an old stack. This has been designed by multiple iterations of developing teams throughout the years, and there's a lot of duplication there as well as a lot of tightly coupled services where if you change one, you have to go into 7 other projects and figure out what is going on. And this was a similar pattern with database as well. Code is untestable. Now, this has nothing to do with architecture, but it was the pattern of the way things were designed at the time. Our legacy code, I say, is I inherited. I'm with the work for 4 years now, so this is kind of inherited legacy for me. It's untestable. It's due to the nature of it being very static and not decoupled. And there's no interfaces, we can't mock, we can't do any of that. Duplication, as I said, across controllers. And this is a funny one. So again, I'm just being realistic. I've been through now 6 companies, and I've seen it everywhere. And I do it in my private projects as well when you are kind of rushing through things. We have duplications. So our mobile API has internal controllers or the external controllers that are actually acting up as endpoints. They will have some specific logic that is serving one app that we have on the iPad, but we have the same instance of the app, but on a web. And that will be on the web forms, and the web forms has the code behind using exactly the same logic, so there is duplication. Yeah, so if we had to change one, we had to change 2, and then it was becoming a problem. The frontend was not reactive, so this is specifically for the web forms projects. The web MVC, like I said, has an Angular. Angular is a bit reactive, so that was great. It's dated, so that's AngularJS 1. Now we're in Angular 15. So dated, but still works very well. So we want to just modernize it a bit. But the non-reactive fact of the ASPX code was slowing us down. And you can feel the difference when you were jumping, because it's all the simplest kind of web application. But when you go from the web MVC and navigate into the ASPX page, the difference is immediate. It's all based on reloads, it's all based on submit forms and all of that. So it is not reactive. Unscalable for the future expansions. Yes, we can't deploy just one. They're all monolithic. They're all bundled up. So what you saw in the previous slide, I'll try to go there, is we have around 5 projects on the web MVC. We have around 6, 7 on the web forms, and we have 1 mobile API. So if we wanted to move one of these out and scale it, no, not possible. And slow builds again. And this is the fun one. This is for us as developers and the development team. Was really hurting us, and you can see why. So build size, when we have fun and we build and we work on our web forms projects, our web client is one of the web forms projects, takes 1.8 minutes to build. Our admin project takes around 2 minutes to build, right? So you come in as a developer and you're like, I want to change one code behind, and you know what, I need to do my end-to-end testing on both the admin and the web client. The reason you kind of build both all the time is the admin allows you to configure something that you're going to see on the client. So if you are performing any change, you want to make sure you expose the settings of the admin, and you want to do both. 4 minutes. Now this is golden if you're one of those developers that wants to smoke, because you go out and you just become a chimney. But if you want to keep momentum, it's very disruptive, because it disrupts your momentum. If you're a developer, and I still am at that phase, where you constantly do trial and error. So you inherit the code, you're working on a function, you think you got it right, you test it, it's like, oh no, there is something I need to change now. You rebuild, it was like, oh yeah, but I missed this now as well. So you do these trial and errors. 4 minutes every time. MVC project is okay if you go by these standards. You're like, this is golden. I mean, 0.2, like 20 seconds, 15 seconds. So it's not that terrible. Keeps the momentum there. API is less than 10 seconds, but it's very small. Full deployable build. So if we wanted to use local IAS and bundle all these 12 applications with the API and the whole 9 yards and do a build and run all our tests and everything from the new world, 10 to 15 minutes. And my CTO says, you're lucky you have the fastest laptop in the company. So it really can be daunting. If you want to perform end-to-end at the end of before a release, I want to bundle everything up, all my commits into one, and I want to test it all and deploy all build. 15 minutes. If I've missed something, redo it again. 15 minutes. So it is very, very slow. So the first thing what came in our minds, right? I mean, I was at this time of the rewrite, I was lucky enough to be promoted to a lead developer, and immediately I went, microservices, right? We have to decouple every single thing. And my CTO is laughing at me in the back room because I came in from a company of building nanoservices mostly. It was microservices, but to the fact that every single service was its own function and it exposed its own endpoint, single endpoint. So the orchestration had to happen. And I went mad. I was like, yeah, we need to go microservices. And we considered it. Like, I was given the chance to consider it. First brick we've hit, I mean, it's the data domain separation was a big no for us. So we built enterprise software for the airlines. The database that we have, it holds, remember, it's a multi-tenancy database. We have around 11 domains, 4 products, but around 11 domains. It's just impossible to shard the database. I mean, some of the newer products that we've built do use schema separation, but most of them are intertwined. More than 100 tables, more than 100 statistics, more than 100 functions. So getting this sharded, impossible for our size at the time. Right, so we were operating at the time, to give you a perspective, around 5 web developers, 2-3 mobile developers, tech lead, CTO. Everybody hands-on, so it's kind of that kind of policies. Yeah, apart from the database, which was a big no, a slap in my face pretty much at the time, high operational complexity. Again, we're a small company, small team. So operational complexity was massive. Distribution policy, how are we going to deploy? Versioning policies, how are we going to automate? So because we are in this kind of very regulated industry, the aviation as it is, we do one release per 2 months. And it has to be very regulated, it has to be signed off, it has to pass these UATs and everything. So we can't really afford to have CI/CD, and also we've never kind of invested into this kind of deployment. And then on top of that, if I go back to the keynote speaker, Alex, who was talking about serverless orchestration, you need to think about resilient message brokers. We are, again, working with the airline industries, heavily regulated. Our margin for error, 0, which means we can't lose a single message. But I said at the topic that at the beginning, the whole topic will be no magic, right? We've built our queues, so we have in our monolithic application queuing system, we use SignalR to open up web sockets, so we do the whole asynchronous, we're just not serverless. We are monolithic. And then ownership per domain, 5 people, 11 domains. Good luck assigning things to people, right? It's gonna be funny. So we went to the approach, and we've been really realistic about this, and everybody went hands-on, and we decided, let's modularize what we have. Start from the beginning, enable the products to be able to scale later on as we are growing. So the first thing we want to do is decouple services, decouple everything so that specific business domain logic stays within the domain. It's not just shared across the board and then reused from different domains so that you can't really touch it when you really need it specifically. We wanted to decouple the front end from the back end. Now, again, it's a very condensed talk, but our MVC is kind of doing it. We have Razor pages with AngularJS, with gulp, so it's not decoupled, it's a big monolith which kind of holds together. But if we wanted to, we can decouple that. Well, web forms was a problem. You can't decouple an HTTP page from code behind, like that's possible. So we knew we needed to go that direction. We wanted to have a gateway. Specifically, so I say a gateway here, and we have a service I call a BFF in big quotation marks, and an API gateway in big quotation marks. The reason I named them like that is because we wanted a service that will provide unanimous authentication for our old world, our new world, and our applications, our mobile applications. Apart from having an iPad app, we're now building a mobile app as well. So we needed one central point where everything will authenticate and act as a server, as an authentication server. Another point was routing. So we wanted this API gateway to be able to route to the appropriate APIs if we wanted to split our APIs down the line and modularize those as well. For now, we just have one. Share single repository is a big one for us. Again, we're a team of 5, so deploying is an issue. We have a huge DevOps department of 1. Sharing versioning and technology standards was a big one as well. If we went for microservices, we can use the same service, but then you don't have to. You have to give the ownership to teams, and that was a kind of problem. So we wanted to be standard. We wanted to use C#. We knew we were all Microsoft to our heart. We knew what we wanted. And one deployment process for all is a big takeaway from here. We still wanted to be monolithic in our deployment processes to begin with, because this was a project for scaling. This was not at a time like we've scaled now, the business has grown, and we're lacking. We're talking, we are growing the tech because we know what's upcoming now in the next 2 years. You haven't, by the way. Right, so what we ended up with in the new world is, and I'll show some diagrams here as well. So we've created 3 modular projects to start with that will allow us this modularity and scalability as I'm talking about. So the first thing is we've created a Monorepo workspace that holds our client applications. We're talking about 11, 12 front-end applications that will be held. That's good. So the Monorepo is holding our web applications, and I'll talk about a Monorepo specifically and what tooling we've used for the Monorepo and why. We have have this BFF core project that I've been talking about, which provides the routing, the gateway for our URS, and serves as a BFF to the front end. This is a big one. So BFF, in its words, is a backend for front end. Now it can be interpreted in many ways, and I like it that it can be interpreted in many ways because it doesn't have to be something you followed by somebody who wrote a book that says BFF has to do this, otherwise it's not BFF. If it provides services for your backend, if it provides bootstrapping, if it provides builds, if it provides value for your backend, and it's unanimized for all your clients in the front end, it is a backend for front end. So that's what we've done, and I'll talk about it a bit. There is a .NET 6 now REST API project sitting underneath this, which holds all our API endpoints. And the reason I say quotation marks gateway is because there is one API. What are you gatewaying to, right? You're not pointing to anything. You're just hitting them up. But the plan is to have more. The plan is to modularize, and this is why we've created a gateway so that when we have more APIs, we have one route that goes centrally and then that distributes it to either go to each service. So it's not microservices, but you can see it's still pointing to that direction. At the end, we have a layer of domain applications, again in .NET 6. The reason you see .NET 6 here is long-term support, so we don't go to .NET 7 now. We started this whole project with .NET, I think it was core 3.0 to 3.1, and then .NET 5, and now in .NET 6. So it's domain applications, so if you have 11, 12 domains, 11, 12 applications, again, in that ideal world, to begin with, it's one project with 11 apps separated into areas and domains. So we're following domain-driven design, but in one project for now, because we want that one single deployment process. And we have a .NET standard shared class library now, so remember that shared business logic that we had across the world because we had .NET Framework 4.7. Because we need the old applications to work with the new applications, or to say .NET Framework 4.7 needs to talk to .NET 6, which you can't target both, you need a class library that's shared, which is targeting .NET Standard 2. And this holds our data entities and our data contexts. This is how the architecture is designed now to look like. So from what we had there as 3 big projects and 1 monolith, we now have our Angular applications. We chose an Angular, and I'll speak about it at the end on why we did that. So our client applications are at the top. We have the mobile app, we have the iPad app. This BFF API gateway project that handles authentication as well as handles starting these clients up is in the middle layer together with the API. And then we have the domain applications, which can be split up into multiple applications if you wanted to, sharing the .NET Standard library. The beast is staying the beast, so the single database will stay the same for now, which is what limits us mostly ongoing microservices. This is how you can envision it now. So pretty much, because we have a monorepo, we get single versioning, single policy, single deployment process, but we still have 4 projects to begin with. There will be more. BFF API, Gateway, and API are kind of bundled together because there is nothing to route now to these one API, but there will be more, so these will become separated. And these are as well bundled as one, just following domain-driven separation without separating the actual project. So to talk a little bit, and I've kind of skipped ahead here, the BFF button to the rescue. Why? The frontend needed to be anonymous. It needed to be started from IIS, and because we had our production code starts and works with IIS, and the frontend we wanted the backend and the frontend to be the frontend to be on IIS server as well instead of using dev service or any part of that. We also wanted the backend to give the routes to call the old world and all of that to the backend, to the frontend. So that's where the BFF is serving our values, becoming the backend for the frontend. It's mostly just serving everything to our Angular application. It handles authentication authorization, I already said that. It handles the paths and the routes, and it acts as a gateway at the moment for our REST services, but it will become more of an API gateway as we grow. The REST API, typical .NET 6 API, open API documentation we use there, fully RESTful as you would expect from all the modern patterns that we use. While with the tooling now, we don't expose one interface for our endpoints. Domain applications, very simple, .NET 6 applications again. We share data entities and context now in the standard library. We use link to SQL, fun, and contain business logic per domain. Right, so the front end, I keep on talking about Angular, and we use that. So we use Angular 8+, and this is where we started. We are now on Angular 13. And we decided Angular for many specific reasons. One of the bigger ones is familiarity. The other one was resource. So we've prototyped, and we are a company that we like to R&D and prototype and bring our findings to the board before we make a decision as a team. And because we use AngularJS, because we are to the heart of Microsoft, we love MVC, all of us are advocates for MVC actually. Angular made perfect sense. We've tried React, we've tried Blazor as well, since we're hard for Microsoft, but I think we use Webpack now for bundling as it comes, but we don't use anything else. And I'll talk about how we actually use Webpack to its full potential. We use a modular monolith, which we'll touch in a bit. Single deployment now with our BFF, so when you run your .NET application, your Angular runs with you. We are in full control, no magic. And we'll see why I say that. So integration, if you're a .NET developer and you've integrated a SPA to your web API or to any template, it's a fun journey. I mean, if you started, we started with .NET Core 3.1, 5, now 6. Microsoft changed their way of integration every single iteration. And it became a problem for us, and the reason these stickers are saying no magic is because we really don't like magic. We don't like something being handled by a third party. So how it actually works now, I'll talk about what the drawbacks are. In .NET 6 at the moment, it can be boot up. You can configure your startup to actually point at your Angular application. It will build it for you, but it will still run a dev server. And that dev server will proxy to your ASP.NET Core. So when you start the application, type in a URL, it will do the proxy. And it limits you in many factors, and I'll talk about why and what the drawbacks are here. So a drawback of using the Magic extension is, one of them is dev and production will run different servers. So production was going to be on IIS, completely on IIS, while dev will be dev server proxied into an IIS Express core host, which was a problem. Controlling the deployment process was another thing. If you see how much control you lose if you want to do this through the startup class, it's enormous. You don't control bundling and unification. You have very little, you have control over your output and the size of the files and everything, but there is very little on what you can do about file loaders and how you can load your assets and all of that. It requires as well different configurations because of dev server and how it runs. If you want to run, let's say, we go crazy here and we say we're going to introduce React as well and Vue on top of our Angular, which we can if we grow to that size that we want to grow in the next 2 to 5 years. So if it will require configuring different file frameworks and dev servers. Biggest part, the no support of Microsoft moving forward. So Microsoft kept contradicting and they kept changing it. So in version 6 they said now this is obsolete and they're not gonna be supporting it anymore. It's no longer an LTS and it's now left to be an extension in NuGet to be handled by the community, which means you're kind of leaving your whole project builds on the community, which is bad. At least for us, because we are those, one of those engineers that really like to have full control over our process. So what we've done is, because we know MVC well and how .NET works and how .NET bundles everything, we decided to take control of over this process and wrote our own way of bootstrapping our Angular apps without using a Gulp or an extension from Microsoft. And how was this achieved? So what we've done is we have created a controller for each application we're going to create in Frontend. So we act up simple, we kind of bring MVC again back to life in our BFF. So for each application in Angular, we create an internal controller. That internal controller will point to an internal view. That view will have Angular somehow inside it that will bootstrap. So when you run your BFF, it runs the Razor view, and the Razor view runs your Angular, purely from .NET using IIS. And each controller is decorated through an authorization attribute, which means we're now handling the authentication and authorization on a controller level with the attributes. The moment the controller then sees the view, Angular routing then takes place, and the auth guards and all of that, lazy loads, you can have them. I said that each controller will have a view. Dynamically is built now by Webpack, and I'll talk about it in the next slide on how we've configured Webpack to dynamically build us a CSHTML Razor view that actually has the Angular app already pre-built so that .NET can see it and just run it. Routing we handled now originally through the app, and this allows us to extend our BFF. So Razor doesn't care what you're giving it, as long as you give it bundled JS, it will just run it for you because it's run its own view, its own Razor view. So how did we achieve this? So Webpack has its native plugins, or obviously native plugins, but they're officially supported plugins, and one of them is it can output a CSHTML for you. So what you do it is you tell it, hey, there is a template for CSHTML with a bit of C# logic and a bit of Razor logic inside, that you tell it, loop through all the files in your outputs, you give it where your bundle files are, your JavaScript, your CSS, and it builds you a layout Razor page that you can actually point to the controller. We're handling now on our own SCSS files, SAS, file loaders. We create our own custom rules on how our assets will be loaded, all through Webpack, so we have full control of that. We create our own source map in the dev environment, and we minify and bundle in production. What this means is now our dev environment and our product environment are exactly the same. So they're both served by IIS. There is no difference in process. There is no proxies. There is no dev server. The only thing is we have two configs. One provides source maps, so you can still debug through your Chrome browser or whatever browser. While in production, we don't allow that, and we minify and bundle. This is how this looks. Very simplified process, but I'll try to blabber through it very fast. So this is the custom integration. At the end there you see a CSHTML template, which we use to as pretty much a template for our CSHTML generation. So to give you an idea of how the process works, this is our .NET BFF. When you start this, it now has an internal controller that is looking for a view. When you start it, it runs a build command for our Angular world and says, build me all your projects. When this happens, Webpack then goes and looks for a template to see, okay, I'm going to use this template and I'm going to spread out everything I've built for Angular app 1, push it in here. Once this is done, I'm going to serve it to the location where the controller is pointing to the view, which means now that there's the view being built. So by the time this is all built, the controllers have their view, and .NET is starting up for you without any help or without any third parties, and you are in full control on what you're doing. And you might say, okay, you've talked a little bit about the backend now, but what about the actual front end? You keep on saying about the BFF and all that. So our approach to create a new front end again was the same journey as our backend. Limited resource at the time. We need full modularity. We need to manage versioning as one big thing across all, but we still want to be able to separate. So moving forward, if we have the training system using up too much resource and that is client heavy, we want to move it out of our VM. We want to be able to do it if we need it. So we need to deploy all projects in one go at the moment, but we wanted to have modularity always in place. And we need our code base to be split up. So we wanted to use DDD here as well, which means splitting up apps and libraries and projects and all that. And we will see how that was done. My first thing again was micro frontends, right? We have to separate everything. We have to use the latest. We have to use, I'm always tempted by those things. And the talk is to talk you to do the opposite, to be tempted and excited to read, but to not implement it for the sake of implementation. So pros, independent deployments, yes, that's great. Different technologies per micro frontend, again, awesome, because you can have your own, every project is in a single repo. The cons are, again, increased functional complexity, and I always say, whenever you're considering micro something, consider your resources first, not what you're solving. Because the fact is, you're going to be introducing more problems and more complexity to your team and company than what you're actually solving. And you can write everything from in your own environment. Even monoliths can be very, very useful. And then increased deployment complexity. Again, if you have 11 different applications, somebody has to take care of it. Somebody has to take care of versioning of those, right? Well, what tools do we have? And again, we have the DevOps department of one, which is fun. So the bigger proposal here was, well, let's just stick with a monolith, right? What is so wrong about a monolithic application? We didn't, but hey, it's easy to maintain to begin with, right? When you're starting to rewrite, it's super fast. Its speed to market is excellent because you just create one project and you start building on top of it. Low complexity in deployments, one deployment, right? One version. The cons are, of course, it's not as scalable. You can't just move one domain of your big application and just do it. You have to create a new project now, you have to have the old version. It can be done, don't get me wrong, you can separate it, but it takes more time to do it. Maintenance of a certain size becomes a problem, definitely, and collaboration. So it has a similar impact on the teams, where microservices, you need to divide it into teams and say, this is yours, own it, this is yours. Monolith is kind of everybody works on the same thing, and that becomes a problem as well. Because not everybody knows the context as you do, maybe on one domain or the other, and if you want to do separation, when you're sharing code, it's becoming a little Right, so here comes the monorepo to the rescue. So I keep on saying about monorepo. So what does the monorepo actually do, and why is it useful and important when you're actually modularizing and distributing? So monorepo as an architectural concept, there's a lot of text here, but allows managing of isolated code inside a single repository. So you can think of it as a micro frontend, but under one roof. So you get the benefits of both, of both the micro frontends and the monoliths, and I'll show the graph why. While you might say this is a question with an answer of me, while you might say, storing multiple projects in a single repo, isn't that a monolith, right? Well, it's not, because in a monolith you have one application, and yes, it's under one roof, but it's one big application. Here we have 10 applications under the same house roof, but the windows are open, because you can move them out. But you can still repair one roof if something is there, so single version policy is here important, and we're using NX there, which I say to help us with our tooling, and NX allows you to build your projects separately, which means they're under one roof, but you can put them in a room and build them separately. Even though they're not treated as a monolith, they're purely treated as micro frontends, but it's under one roof. And this is how this looks on a very, very high level. One monolith will have, if you have one monolith, and we have it, one big application, 11 domains inside, it serves, multiple domains, shared code base, single deployment, great, but not at our size. Multi-repo is awesome. If you have 15 front-end developers and 7 people to handle your deployments, amazing, right? I'm not against them, but they're resource heavy. These have complexities, and then the monorepo comes in between, where you can create multiple projects, you can still have the separation, you can have different technology per application, but one package file, one workspace file, right? One versioning code, one deployment process, and you can build separately if you want with NX. So what is NX? Right? So NX was created by the Angular team in Google. So when they were working on Angular, a couple of developers started their own company called Norwich, to get that right. And it provides the NX toolchain in consultation and education. So it's a TypeScript-based tooling kit that is sitting on top of the Angular CLI, pretty much. So it uses the same functions. If you're familiar with Angular, I'm talking about Angular, my experience, but I think with Java it's exactly the same, because they support all technologies. You pretty much, if you do an ng build, you do an NX build here, but it allows you to do more. It sits on top of it. Very big win here is it has computational caching, and I'll talk about it in a second. and it manages your NPM dependencies in a single package file. As I said, and this is used by Google, so Monorepo uses Google uses Monorepo everywhere in the tech stack. What does it do better, right? All that single policy is great, but it also offers more goodies. So you know that little other, it doesn't stop there, right? So it has an NX affected and a depth graph, what we call it. So what is NX affected? Affected is a type of build where it just builds what was affected by your code change. So it looks at the difference, and if you, let's say, check out a commit and you just work on something, it checks what that something you write or a component you've changed, what is affected by it, or where is it implicitly imported, and it will only build you that if you wanted to. It can also give you dependency graphs. So it can give you a dependency graph on your whole monorepo or per project, which I'll show in a second. But it can also give you a dependency graph on what is affected, which means if you are coming into our team, for example, we are hiring, and then you work on a piece of on some component that is coupled tightly, you can run NX dependency graph affected. You can see what you're doing is where is it affecting it. So it's super, super cool. Very simplistic depth graph. If you had 3 applications, for instance, and you had 4 libraries, you can touch application 1, and if you run NX affected builds, it will only run you application 1 and 1 is affected there. If I'm touching library 3, it will only build me library 3 because there is nothing else. But if I'm doing library 1, it will do the app 1 above it. If I'm touching app 3, if I do a whole build for app 3, it will just do library 4. So I would advise, because again, this is a very condensed time slot, go on NXDev and see what how it actually looks when you do a depth graph. It's actually super cool. I said it has a very cool concept of computational caching, and it is really, really interesting. So it's a powerful concept because it allows you to cache your builds. What this means is, and it does it locally to begin with, you don't have to even configure it for it, but if you want to, you can do it in the cloud. So the concept is similar to build once, run everywhere, similar to how you have it in Docker. What this means is if I have an application, I build it locally, that's now cached. What that means is if I try to rebuild it, it's 0.1 seconds, 0.2 seconds of rebuild. If I change something, it looks at the cache and what is changed, and it looks at its, again, affected abilities, which means it will only rebuild me what is changed and give me the rest with the cache. Which means even if I do a change and a rebuild, rebuilds are 0.1 seconds. You will see how this works. The good thing is in bigger teams and again corporations, and if your teams are split up in different countries and all that, it's really useful because it has cloud computational cache as well, which means if you have a repository you're checking out or a commit and you build it, it goes to the cloud. Next morning somebody from Poland goes in and just checks out your commit. They get the cache that you uploaded on the cloud, which means their build is instantaneous, and then they go from that cache and upload theirs. It's amazing. It's an amazing tool for working right now. This is our world right now, where we are with the migration. So 3 apps have been moved slightly, and they're buildable, and they're working now into a completely new world, served by the BFF, with their Angular 13, shared libraries across in the Monorepo. If I did a full build of the 3 apps with a command of skipping the cache and not using the effect, because you can tell it, just do pure builds, 68 seconds it takes to build the whole thing. So our whole backend, imagine, plus the apps, so this is the whole 9 yards. If I build 1 app, so if I tell the compiler build me everything, but just give me app 1, not the 3. And this is the powerful thing of a monorepo. You don't have a monolithic application where you can choose, I just want that domain. You can't do it in a big app. But with monorepo, you can. You tell it, hey, I just want app 1. And it's 130 seconds. And app 1 is the bigger one. But the effect is where the value comes from. And this is where I said, remember, if you're a smoker, you would love our web forms applications because 4 or 5 minutes is like super, super convenient to have your coffee and cigar. Well, you can't now. I mean, we've kind of trapped you in the company. So point 3, you don't lose the momentum. You constantly are, your refreshes are super fast. And this is really important. So to give you another benefit of this, so because the BFF bootstraps everything, it all goes through .NET. And with .NET 6, we have hot reloads. I think they came with .NET 5 or 3.1 or something. They came in as an extension, then they're now built in. What it means is because we have hot reloading and checks on our .NET, remember our process that is not magic? So we have a Razor view that actually is bootstrapped into the controller that looks at the view. Because the view changes constantly when you do rebuild, because the Webpack will bundle a new view for you and put it there, .NET thinks you made a change. And because it thinks you made a change in the view, it reloads for you. Which means your whole application, when you started from .NET and you want to change just one thing, you press save in 0.3 seconds or less, your page refreshes with your change. You want to do something, you click save, it's instantaneously there. So the development speed insane. I mean, when we were prototyping with one of the engineers in the room, actually, and we were testing out Monorepo and how it will affect our productivity, we were writing libraries at the time, shared libraries for all our applications. When we were first playing with the idea without a Monorepo, we got interrupted every 5-6 minutes, right? We need to rebuild, okay, let me get a wall. You know, the constant interruptions were there. When we introduced the hot reloading and all of that, we've done it in half an hour, which something could have taken 3 hours because of the interruptions. It's the soft skills you're using there. So to summarize, less boilerplate, less configuration. You have one script for a whole Monorepo instead of doing multi-repo, sorry. You promote modular architecture out of the box. So NX even tells you go for DDD, create apps, create projects, and create libraries. And these libraries, as long as they're under the one roof, they can talk to each other between different projects. If you want to separate them, the libraries can go as NPM packages or artifacts, move them to the cloud, and you can move 1 to 5 applications of your Monorepo independently, and they'll still be able to communicate, which is amazing. And then sharing components is naturally evolved here, because we have components that sometimes you might find, well, you know what, they can be reused. And if they can be reused, you can promote them to a library very quickly and very easily with NX. Right, so let's close the circle. So the REST API project calls are REST endpoints. That's a normal. The BFF now provides routing, authentication, internal controllers for our Angular apps, and it builds the Monorepo. The Monorepo holds our Angular applications in a single repository. We're following DDD. So every application we're splitting up into features, core, domains. So we're kind of following it by the book. Webpack now is configured to create our CSS HTML views, which get loaded in the BFF, and then bootstraps our client application. So we no longer have any magic in the actual circle. And .NET 6 change detection sits on top, so that any little change, as I said, gets hot reloaded on the fly. So what was achieved? Going back from that 5th slide where we had this very condensed monolithic application, we now have a unified modularized project, distributed project that we can scale at any time we want it. The backend can be split up into independent services anytime. We have a gateway that can support that. The modular frontend can be split up into independent multi-repo. We can do that, it's not a problem. No magic. So, I need to end this with a motivational quote. Yeah, so we're not going to be cheesy, but I hope this has intrigued you to take more pragmatic and innovative approach. So I'll say again, contrary to the presentations we had about serverless, which are great, I think, you know, thinking about what a service actually does, what you can do for your own architecture to control it and to allow you to do the same thing that maybe a serverless service will do for you. Think about it. Always be pragmatic. Always find the solutions that suit your needs. And what you saw today suited us perfectly. Yes, it might be a bit more complex. Yes, you might think we've kind of reinvented the wheel, but we didn't. We actually produced something that works really well for us as a team and for the company. And it allows us to scale very quickly. Additional resources. So if you want to, I'm new to the scene. If you want to get in touch, Kire, Simonovski.co.uk if you want to see my site. There's a blog. I blog a lot about architecture lately in the last year. I talk about microservices quite a lot there, synchronous, asynchronous communication, building resilient brokers and all that. K2TechSolutions.com is a personal blog of mine. We are an exciting business. If you want to learn more about where I am at the moment and what we do at Evoke, go to evokesystems.io, hit the career, we're hiring. And if you want to know more about architecture again, Microsoft offers a crazy amount of information for free. So the Azure architecture sites, visit them, they're really useful. And try out NXDev. Whatever technology you're using in the front end, you can do back end as well as a Monorepo. If you find uses for that, it's really, really good. And the laptop crashed at the perfect time.